And it's 0 because there isn't a number being added outside of the absolute value symbols. So she is 100% correct. The vertex would be 60, 0. So that means that's where our graph is going to start. Now, when you're graphing and we have 60, like, no, I'm not going to count by ones, but counting by tens might be pretty good. So I'm just going to count by tens here. And whatever I do to one axis, I need to count the same way with the other one. That keeps our axes equivalent so that one axis is equivalent to the other. I'm using the same proportion to represent each one of those tick marks. This one here got a little sloppy, that 40. So we're going to graph this vertex at 60. That's my x value, comma 0. So we're on the x-axis. And then remember, the slope of this graph is the number in front of the absolute value. Well, that number in front is really a 1. And I have to use a positive slope on the right and the negative slope on the left. So my a value on the right is a positive 1. My a value on the left should be a negative 1. I should have the same line increasing and decreasing connecting at that vertex. So up 1 over 1, up 1, backwards 1. And I'm going up and like left or right, up, left or right. And that gives me that positive and negative slope. So my absolute value graph should be a V, and this would be my V. So now I have a graph. The second part of it says, for what values of A will E be 2.5 miles per hour? So in the equation, we're trying to find values for A when the E would be 2.5 miles per hour. Remember that E is the error. So if I had an error of 2.5 miles per hour, what could my differences be in speed? That's what the question is really asking. So if I take the E out and replace it with 2.5, I now have an absolute value equation, which we solved in chapter 1. Remember, in math, you learn it, you use it. You don't forget about it in math. So once you learn it, it's fair game for it to come up again and again and again and again. So in this question, how do I solve an absolute value equation? Alyssa S., do you remember how we solve an absolute value equation?
Would the absolute value determine where it goes on the line?
It would determine where it goes on the line, but do you remember how do we actually like solve this? I want to get A by itself. How do we actually find it algebraically?
Add 60 and get it by
We would add 60, but I need to do something to make two equations. And that accounts for the positive and negative slope of our graph. So I'm going to get rid of those bars because we can't solve for A with having bars around it. We have to isolate A, get rid of those bars. So one of them stays as A minus 60 equals 2.5. That accounts for the positive side of the graph, the positive slope. And then the other side, I would say A minus 60 equals negative 2.5. That accounts for the negative side of the graph. That's why I have these two equations, because my graph has two sides. So then, yes, Alyssa, we would add 60 both times. And I would get 62.5. And I would also have 57.5. And that's in miles per hour. So if the error of my speedometer, meaning if it wasn't reading correctly and it was off by 2.5 miles per hour, I could actually be going 62.5 miles per hour, or I could be going a little slower than what it's reading at 57 miles per hour. On my graph, if I drew a line at 2.5 that goes through the y-axis, I'd be looking at that lower part of the graph. That's really close to the vertex or the V of the graph. Any questions? Ooh. Julia.
Is there a reason why we didn't use negative 60 and use 60 instead?
Say it again.
Is there a reason that we use 60 instead of negative 60? Because it said
Yes, because the actual equation or formula has a minus sign in it. So that's part of the formula. That's part of the equation.
oh, okay.
60 is just the number.
Okay, thank you.
So the minus sign is not attached to the 60. That minus sign is just part of the formula or the way we write the equation. So that's like the standard way to write an equation, x minus. So the 60 is just the number that's sitting there. Other questions? All right, so I'm going to go through number 37 a little quicker now that we kind of remember what's going on. So this one's talking about sales of new basketball shoes and the increase for a white and then a decrease as a function. And it's giving us for increase and then decrease as described by the function. It has S equals S for sales, -2 absolute value of t minus 15 plus 50. And it says t is time in weeks. Okay, so the S is the sales, the t is the time. And it shows that we have an increase in the function, and then it says you're going to have a decrease in the sales. It says to graph it, and then what is the greatest number of pairs of shoes that could be sold in 1 week. So we're going to graph this the same way. So looking at this equation here, the first thing we need to think about is the vertex. Annabelle, what would the vertex of this equation be?
1550.
Yeah. So again, we're taking just the number 15, and then it's a plus 50 outside. And the reason it's just the number 15 is because in the equation, there's a minus in the standard form. So when I go to graph this, I have to graph that vertex at 15 and 50. So maybe I'll count by fives this time since we have 15. I'm not going to label all of them. Okay, so we have our vertex at 1550. So over 15 up to 50. And that's where we start our graph. That's the vertex. And then if I'm looking, the number in front is -2. So I'm going to graph that slope on the right side. On the left side is the positive value. So I should have the same slope on the left and the right, the same value, but one should be increasing, the other one should be decreasing. Then I'm going to apply the slope to my vertex. So it's down to right 1 because I have a negative graph or negative slope on the left or the right. And then on the left side, I'm going down 2, but I'm going backwards 1 because that should be a positive slope. And if I go down and backwards, that really represents a positive increase. So here would be my absolute value function. Still should be a v. Remember, if I don't get a v, then I didn't graph the slope correctly. So based off of the problem, it says that it has a steady increase and then a decrease. So it increases to the peak, and then it has that steady decrease on the other side. So what's the greatest number of shoes sold in 1 week? So each one of my x values represents 1 week. What's the greatest number of shoes that we sold in 1 week? So you have to think, what does the equation mean? What is it talking about? Which one of those values represents the number of shoes that we would have sold? So look at the equation. Does the x or the y represent the number of shoes that were sold? Brooke, what do you think? How many shoes did we sell in 1 week? The greatest number.
Would it be 15?
So 15 represents the week. So the 15.
Oh, so it would be 50.
Yeah, so the 15th week, and the reason 15 represents the week is because the t variable is really my x variable. So that's time. So in the 15th week, we sold 50 pairs of shoes, I guess basketball shoes. So the y value are the sales that we've sold. T is time, that's my X. The sales would be the Y. Jaden.
Sorry, I don't mean to like correct you or anything, but shouldn't it be 50,000? Because it says in thousands.
That is correct. So it does say in thousands. Good check there. Making sure Mrs. Kane is on her game on a Monday. Yeah. Nice job, Jaden. Thank you. Good catch. I think I totally skipped right over that when I was reading the problem. Questions on graphing absolute value, especially absolute value word problems. So you can always change your X and Y axis. You know, we don't always have to count by ones, but make it the same increment. Whatever you count on the X, you need to count on the Y. Okay. So what I'd like you to do is find that chapter 2 packet. We're going to quickly go through a couple more problems with absolute value. And then we're going to transfer over into talking just about transformations in general. So I am looking at page 25 in your packet. And at the top of page 25 is example 3. So this is a nice review to just kind of make sure everybody feels comfortable about trying to write an equation for a graph that's shown. So corresponding to your homework would have been 15 to 20. So if I have an equation, can we create, or I have a graph, can we create an equation matching that graph? And we're going to be writing our equations in that f of x notation. F of x and y are the same thing, but f of x means it's a function. It means our graph passed the vertical line test. So if I know it's a function, we usually don't use y. You're going to see f of x pretty much throughout the entire year. Very rarely would you see the y in an equation. So f of x means we have a function. So if I'm talking about a function, I use f of x instead of y. When we write an equation, we need to kind of think about what the slope is. And then we also need the vertex. So there are two things that we need to find to write an equation. So we need the a value, and then we need the vertex, which would be h and k. And remember that negative sign is part of the equation. That's part of the formula. It's called the standard form. So looking at the graph, let's start with the vertex. Faith, what's the vertex of this graph?
It's would it be -1, 3.
-1, 3. So here's our vertex. And then Faith, if you look at the positive side of the graph, the right side of the graph, that's the side that creates our slope. It's always the right side, which is kind of like your main side. What would the slope of the right side of that line be? This right here?
2/1.
Yeah, 2/1. So we're going up 2 and over 1 to get to the next point. So that's our a value. So that's all I need to write an equation. So I need a vertex, and we need an a value. So if we plug those in, the a is 2 using the right side of the equation. The left side of the equation is the opposite, so we're using that right side. It should be positive because my graph goes up. And then in parentheses, we have x minus, well, we're plugging in a -1 for h. And then the k value is a +3. So that means if I have x minus -1, that's how it turns into a +1 inside the absolute value. So my final equation would be f of x equals 2, absolute value of x +1, because there's a minus in the equation, but my h value is also negative, and then +3. The k value in the equation out here, it's a plus sign. So because it's a plus sign, it's whatever the sign is that takes on that k or y value of your vertex. Any questions?
So would you leave that like that then, or do you have to split it?
Nope. So our goal is to write an equation, and an absolute value equation is just one equation. We're not splitting it up.
Okay, thank you.
If I look at the 3 equations that are down below, they're written in that same form, except they have a y instead of an f of x. Other questions? So what I'd like you to do in the independent practice, we're going to do the one in the middle. And then there's a couple more warm-up problems on the other page that we're going to look at kind of to think about just transformations, but we're just going to graph this one in the middle. So I should see two things to know that you're kind of understanding what the numbers in the problem represent. We should first look at the vertex of the equation that you're given, because that vertex kind of needs to be the focus of our graph. So we have y equals, doing this one in the center, -4, absolute value, x plus 3. And then outside is a plus 1. So Grace, what would the vertex of this equation be?
3, 1.
You're really close. So
-3.
because really inside, I have to think about that -3 as being x minus -3. That's really what that plus means, because the equation has a minus in it. So that's why the vertex is -3. So I'm going to graph that vertex first, going over to -3 and up to 1. So when you see a plus inside, that is really saying x minus, because the general equation is x minus. And then the -3, because the plus really could be two negative values multiplied together. The next part is our a value. Well, the a is the number in front, and that's -4. So the number in the equation goes with the right side every single time. And then on the opposite, the left side, would be a +4. And that's my slope that I'm applying to that point that we're applying to the vertex. So from the vertex, we're going down 4 because it's negative, right 1. Down another 4, right 1. Now on the left side, I'm still going down 4, and I know you're saying, but that's still negative, but I'm moving backwards 1. I'm moving left 1. And notice now I have 2 points that are exactly kind of corresponding with each other. That vertex is in the middle of them. This has symmetry. Last year from symmetry, symmetry cuts the graph in half. So I'm going down 4, right or left 1. So I'm moving down and right, or down and left. And I should have 2 pairs of points matching up each time. Then I'm connecting and making my absolute value. This graph goes down because of the negative sign in the equation. Remember, that flips the graph. Questions? So we're not going to graph the other two. If you feel like you need extra practice, you can feel free to graph the other two, but we're not going to graph the other two. We're going to go to 3 more problems. I guess that I thought were there, but aren't there. Do you guys have 3 more problems? No?
Our next thing is what's on your screen as well.
Okay. I have a different page in mind, so that's okay. So we're going to look at these transformations, and we're going to see if we can describe what's happening with the graph. So this is in general. That means it doesn't just have to be an absolute value equation. It can be any type of equation, and this kind of takes us from here throughout the rest of the year. So every equation, the pieces of the equation do the same thing. It has the same effect on the graph. And that is the goal of a transformation, to understand that where the letters are located, they each represent something in the graph. So if you look at the equation that they're giving you, we have y equals a, and then it says f minus h plus k. This form is the form that we will be focusing on for 8 different types of graphs. So we cover 12 chapters, but 8 of those chapters, or actually 5 of those chapters, are going to have 8 different functions. The F in the middle represents whatever notation or whatever operation is being done with X. So the ones we looked at today are absolute value, but that F just represents what's happening to the function. So reading the directions, it says step 1, stretch or shrink the graph of y equals f of x vertically by a factor of a. If A is greater than 1, it's a stretch, a vertical stretch. So that's the thing that you have to remember. We're talking about vertical. So if the number in front is bigger than 1, then it's a vertical stretch. If the number in front is less than 1, meaning a 1/2, a 3/2, a 2/3, a 5/6, a number less than 1, then we call it a vertical shrink. But you have to remember that we're talking about something vertically happening. So a vertical stretch versus a vertical shrink. So yes, you can say it's getting wider or it's getting narrower, but we're trying to think about why. What's happening with the y value of the graph? So that's the first thing we're going to think about. The second step says reflect the resulting graph. I would reflect it if there is a number in front of x, or in the number in front of the absolute value, that is less than 0. So like the one we just did. So the one we just did, the a value was 4, and then there was a negative. So we would say this is a vertical stretch. It got narrow, and it also flipped. So if I was explaining what that a meant, it flipped, and it was a vertical stretch. And that's just the number in front. It tells us two different things, vertical stretch and it's flipping. So those are steps 1 and 2, and we're going to see if we can try and apply that information. The last part it says is translate. Remember, translate means move, slide, shift, whichever words you want to think about with translate. So after I apply the stretch and the reflection, then we're going to shift the graph. And we're going to shift it by whatever h units are horizontally, meaning left or right, and vertically k units, which means we would go up or we would go down. Now I know that's a lot of information, but that's really what we were doing with our absolute value graph. So if I go back up to the one we just looked at, I can see that this graph went left 3 and it went up 1 because my k value is moving it up and the h value is moving it left because it's a -3 for h and a +1 for k. So what we're going to try and do is apply that to a graph that wouldn't necessarily be absolute value. So I should be able to apply this to any graph, not just an absolute value equation. And the notation is a little different. So this says the graph of y equals f of x is shown. So just look at the graph. It's that first one on the left. It looks like a little check mark. It's just a random function. It's a random graph. It doesn't have an equation that matches with it. But they're calling that graph f of x. So this graph right here on the left is f of x. Our goal is to sketch the graph of a new function based off of some type of transformation that's being done to the equation or that's being done to the graph, since I don't really have an equation to work with. So letter A says we want to take 1/2 times f of x. So let's talk about what it means from up above. The 1/2 is the a value. What does that a value do to the graph from the 3 steps up above? So what would that a value do to our graph? Thinking about what kind of number that is and what kind of stretch we would have. Jordan, what do you think? What would that a value do to our graph?
It would shrink it.
Yeah, so that a value is going to give us a vertical shrink. So this graph should have a vertical shrink. All right, so now we have to think, how do we apply that to this crazy graph? So the way that we apply it to the crazy graph that we have, this little check mark, is to think about the ordered pairs that are already in the graph, or already in this picture that we have. So I'm going to make a little t-chart underneath. And I'm going to take the 3 points that they have on there, and I'm going to write those 3 points in my t-chart. Because I don't have an equation. So this isn't an absolute value equation, it's just a little check mark graph. So starting on the left, I'm looking at that point on the left, and that point is at 0, 4. So I'm just writing the points that are plotted. My second point, the vertex, it kind of looks like a vertex, is at 1, 1. And then the third point on the right is 4, 3. So if those are my original points, how could I use those points to have a vertical shrink in the graph? Because that's what it tells me to do. It says stretch or shrink the graph. That's the first thing I need to do. So how would I get those points to shrink, since Jordan said this was a vertical shrink? A little weird to think about. What variable would you think about being vertical if we have an x and a y? Which variable usually represents a vertical change in your graph? Alyssa, what variable would be a vertical change in our graph?
Y.
Yeah, y. So what we're going to do is we're going to take the y values and we're going to multiply all of them by 1/2. Because this is 1/2 times f of x, but f of x really represents y. So I'm going to do 1/2 times y. That's going to give me a vertical shrink. So after we graph it, we should see this graph kind of like shrinking down vertically. It doesn't do anything with x because x is horizontal. That's left and right. So my x values are going to still be a 0, a 1, and a 4. But now I'm going to take the y values that we have and multiply all of them by 1/2. So my first y value was a 4. Half of 4 is 2. I should see now a vertical shrink in the graph because it's half as much as what it really was. Then I had a 1, so now I'm at 1/2. And then I had a 3, so then that's 3/2. Multiplying each one of those by 1/2. And then we're going to graph them. All right, I'm going to plot these points. So my new point that I'm plotting is at 0, 2, instead of it being at 0, 4. And then at 1, I'm at half. I'm half as much as where we were. And then at 4, we're up at 3.5. So my x values didn't change, but my y values changed because I was shrinking this graph. So if you look at your graph compared to what we have, you can see that the V part, that check mark, it kind of got a little wider. But vertically, it's squished. It shrunk vertically. Questions with that? So I focused on the original x, y values, and then we took all of the y's and we multiplied them by 1/2 because a vertical shrink is affecting the y value. We're going to try and do this one more time with the next problem. I know it's a little weird because you don't have absolute values. There are no symbols in the graph. You just have this F thing. So before you do anything, first decide what happens with this graph. Describe the transformations. So that would be the first thing that you want to focus on. Valerio, what would the transformations of this graph be?
It would be a shrink and
So let's talk about the negative. What does the negative do to the graph?
reflect it.
It reflects it, right? So the negative flips the graph over the x-axis. Okay. What else is going on, Valerio, besides that negative sign?
Vertical shrink.
If there's only a negative sign in front of it, that number with the negative sign, what's the number with the negative sign?
1.
A 1. So it's a 1. A 1 isn't going to change a graph. So if it is equal to 1, it's just a normal graph. It's not going to shrink. It's not going to grow. So you have to think of the negative sign being the part that makes it go down, and then the actual number that's there is really a 1. So that isn't going to shrink or vertically shrink or vertically stretch a graph. How about the other numbers, Valeria? What's going on with those numbers?
We have a 2 for the k value.
Yeah, you're right. The k value is 2, and I rewrote it. Had to show that minus negative. So the k value is 2. That's our y, so that means we're moving up 2 units. And then what else, Valeria? What else is going on? H.
Oh, we know it's a positive h.
So a plus 1 really means in the standard form it's x minus a negative 1. So I rewrote it into that standard form. So that means h is really
-1.
-1. And if it's negative, what direction would that move? Left or right?
Right?
Which way would be the negative side of the graph?
Left?
Yeah. Okay, so this is a little tricky. You really have to kind of look at the numbers and think about what they mean. So even though there's a plus 1 inside with the x, that's really saying x minus -1. That -1 is the value that moves it left or right. That's h. And you might need to write some stuff over here to kind of like give yourself an idea of what it's representing. So x minus -1, the h is -1, which moves the graph left. The number on the outside, that plus 2, is our k value. That plus 2 moves the graph up because k is moving the graph up or down. So now we're going to try and apply that to our points. And I'm going to make like a little kind of rule chart over here. So we have that our graph is moving left 1. So I'm going to take that and write it up here for my x value to remind myself that I have to move left 1. And then the y value, I have to flip it over the x-axis. That means I have to take y and multiply it by a -1. That's what that -1 in front is really doing. We're taking y and we're multiplying it by a -1. And then I need to move it up 2. So I'm writing my little directions here in my t-chart. So here's where it gets weird. I have to take my original x value. So my original x was a 0, my first point. I need to move that 0 left. Well, if I'm moving it left, I have to subtract 1 from it. So now it's a -1. Give myself a little more room here. My second point was a negative or a positive 1. I need to subtract 1 from that. So I'm taking my x and I'm moving it left. But to move it left, I have to subtract. That's what left means, subtracting 1. So now that new point is at 0. And then my last x value, I also need to subtract 1. So that new point is at 3. So when you look at your x values, they should be moving to the left. 1 less than what was originally there. Now the y value, I need to make it negative first. So I got to do the negative part first. Order of operations, multiplication becomes before addition or subtraction. And then I need to move it up 2. So I have a 4. I'm going to make it -4 and then add 2 to that. So now I have -2. I had a positive 1. I'm making it negative and adding 2. So now I have a positive 1. I have a positive 3. I need to make it negative and I need to add 2. So now I have a -1 and then I would graph it. And I know I'm out of time, but I'm going to graph this just so that you can see. So I followed my rules, and now I'm plotting the points. So -1, down 2, 0, up 1, over 3, down 1. My graph should be exactly the same as what I had before, but it should be flipped down, so I can see it's flipped downward, and it's also shifted. That vertex has shifted. Questions? So there are 3 or 4 homework problems, I think it's 3, that you'll have to try and do these translations. Please write the original ordered pairs. I want to see those original ones, and then I want to see your new T-chart. That's like your work. How are you thinking about moving the ordered pairs? They're a little tricky, so there's a couple on there. Jaden.
Sorry, I don't get why did you make the y values negative when you're like over here?
So in the equation, there is a negative right here in the front. And that negative is really our A value. It's really a -1. So in the
Oh, okay.
problem, I multiplied the y values by 1/2. In this one, we're multiplying them by -1. So whatever's in front, you have to multiply y by that number in front.
So basically that's making the whole equation negative is what you're saying.
Yes, that is exactly.
Okay,
You're making the whole.
thank you.
You're welcome. Other questions? These are tricky because you're not really thinking about a random graph and trying to plot points with a random graph, something you have not done before. All right, so I went 2 minutes over. Thanks for sticking around for 2 extra minutes. We'll go over, obviously, a couple of those problems tomorrow to start class. Have a fantastic Monday.
Have a good day.
Thanks, you too.